Welcome to The Explainer. Today, we're diving into some really cool research that tackles a massive question in AI. How in the world do you teach a 40-ton truck to think? Well, it turns out researchers at Chalmers University and the Volvo Group have a pretty groundbreaking answer.
I mean, that really is the heart of it, right? We're not talking about your average self-driving car here. Think about it. A 40-ton, fully loaded truck. That thing has enormous inertia. It completely changes the flow of traffic. So teaching one to think for itself, that is a monumental task. And the stakes for getting it right, or, getting it wrong, are incredibly high.
All right, so let's get into it. The goal here wasn't just, don't crash. The researchers were aiming for something much bigger. They wanted to create an AI that could make genuinely smart, tactical decisions, constantly weighing the need for absolute safety against the real-world demands of economic efficiency. And this is what makes trucks such a unique puzzle for AI. A truck can't just react to what's happening right in front of it. It has to be playing chess, thinking moves ahead. Because of its sheer size, something as simple as a lane change requires cooperation from other drivers. Every single decision it makes sends ripples through traffic, affects safety, and, of course, hits the bottom line, the cost of moving all that stuff. Okay, so if you were tasked with this, what would be your first instinct? You'd probably think, all right, let's just build one giant, all-powerful AI to control everything. And that's exactly what the researchers tried first. We're going to call this the micromanager approach. With this micromanager model, the AI is literally in charge of every single little thing. It's got its hands on the virtual gas pedal, the brake, the steering wheel. Every single second, it's making a new decision about exactly how to physically operate this massive vehicle. And you can probably guess where this is going, right? It's just a lot. Every second, the AI has to look at the road, pick a super specific low-level command like speed up by 1 meter per second, do it, and then boom, start the whole loop over again. It's this constant, frantic cycle of tiny decisions. And yeah, as you might imagine, it's not the best way to learn something this complex. But this is where things get really interesting. This is the breakthrough. The researchers realized the AI was just getting lost in the weeds, totally bogged down by the nitty-gritty physics of driving. So they decided to give it a promotion. And this chart just lays it out perfectly. Instead of being that frazzled micromanager, the AI becomes a calm, strategic manager. It stops worrying about how to press the pedals and starts focusing on what the overall goal is. It's a total shift from making hundreds of tiny physical tweaks to making a few key tactical choices. So, in this new model, the AI's job is completely redefined. It's now the brain of the operation, the leader, making the big picture calls. But if the AI isn't actually driving, who is? Well, these are the kinds of commands the manager AI is now issuing. Instead of saying accelerate by 0.5 meters per second, it's thinking strategically. It's saying things like, okay, let's establish a medium following distance of 2 seconds. Or, the coast is clear, let's initiate a lane change to the left. See the difference? These are strategies, not physical actions. And this is the other half of this brilliant new team. The AI manager's commands get sent down to a low-level controller. Think of it as a skilled employee who's an absolute expert in vehicle physics. This controller has one job and one job only, to flawlessly execute the manager's strategy. It handles all the nitty-gritty of accelerating and braking to meet the goals. It's a perfect, elegant division of labor. All right, so the theory is fantastic, right? You've got the manager, you've got the employee. It makes perfect sense. But does it actually work any better in the real world? To find out, the researchers ran thousands of highway simulations. And the results? Wow. They weren't just an improvement. They were a total game changer. Just look at this graph. It tells the whole story. The original Micromanager AI, it crashed or made a serious error in almost 30% of its runs. Think about that. Nearly 1 out of every 3 trips ended in catastrophic failure. Now, the new strategic manager model, it dropped that failure rate all the way down to just 1.6%. That is a mind-blowing improvement in safety. And it wasn't just about avoiding crashes. The new AI was just better at its job, plain and simple. Take a look at these numbers. The strategic manager actually got to its destination successfully almost 98% of the time. The old micromanager, barely 70%. And because it was so much safer and more confident, it was able to travel way further on average. It was more reliable, more effective, and profoundly safer. No contest. Okay, so we've got a truck that's dramatically safer. That's huge. But in the world of freight and logistics, safety is only part of the puzzle. A truck also has to be profitable. It has to make business sense. And this is where the researchers added another really clever layer of intelligence. They basically taught the AI to think like a seasoned fleet manager. They did this using a reward system they called total cost of operation, or TCOP for short. All of a sudden, the goal wasn't just get there in one piece. It became get there in one piece and do it as cheaply as possible. So now the AI has to do this constant, complex balancing act. If it drives faster, that might reduce the driver's wage cost for the trip, but it's going to burn way more fuel. If it drives slower, it saves on fuel, but the trip takes longer. And of course, a crash comes with a massive financial penalty. The AI had to learn the perfect strategy, juggling all these competing factors to get the absolute lowest total cost. And you know what? It worked incredibly well. The AI trained on this cost model didn't just learn to be safe. It actually learned a strategy that was more economical than the default rule-based driver in the simulation. It figured out how to save money, getting the total trip cost down to 3.74 euros, which actually beat the baseline model's 3.85. It learned to be a smart business decision maker. So, when you boil all this amazing research down, what's the one big idea we should really walk away with? The crucial point, the big takeaway, is this really powerful design principle. When you're trying to solve incredibly complex problems with AI, trying to build one single system that does everything is often a recipe for failure. The secret sauce was freeing the AI from the messy details, from the physics, so it could focus on the bigger picture. You let the AI be the strategist, and you delegate the execution to a specialist. That's the key. And that really leaves us with a fascinating question, doesn't it? This manager and employee model. It's a fundamental breakthrough. If this approach can teach a 40-ton truck how to think and drive safely and efficiently, just imagine, what other complex systems could it unlock? Think about robotics, or manufacturing, or citywide logistics. The possibilities are huge.